Welcome back to this video on statistical interval. Today we focus on confidence intervals, specifically on prediction interval. Here we have a problem on which the analyst wants to know based on the samples collected so far, the two-sided interval within which a single future pH observation is likely to lie with some level of confidence. The average pH, which is the mean in this example, is 6.52. The sample standard deviation S is equals to 0.11. The confidence level chosen is 95%, or A is equals to 0.05. We have a table on the sample, and upon this sample, they have a certain pH level from 1, which is equals to 6.39, until 10, which is equals to 6.62. On this problem, we use a new formula in which we will see. The new formula per se is x bar plus minus t 1 minus a gamma n minus 1 times S, which is the standard deviation, over 1 plus 1 over n. The sample mean is equals to 6.52. All the data are given. So let's all input it. It's equals to 6.52 plus minus 2.262 times 0.11 divided by 1 plus 1 over 10. I have calculated on the calculator the value of this and find it on the table, in which it arrives at this value. This S is equals to 0.11 and this one, which is equals to 6.52 plus minus 0.26. So the interval in this case is 6.26. Sorry for the misconception. And 6.78. The interpretation of the interval is that if successive samples were pulled and tested from the sample population, in other words, the sample batch or same lot number, 95% of the intervals calculated for the individual sample sets will be expected to contain a single next future pH reading, which is this value. So welcome. We are back at it again on this video on prediction interval, confidence interval. So here we have another example. So let's get live right here. We consider the tensile addition test on specimen of titanium alloy. The load at failure, for which the sample size is equals to 22 specimens, was observed, and we found the mean is 13.71, and the standard deviation is equals to 3.55. The 95% confidence interval on mean was between 12.14 and 15.28. We plan to test it on the 23rd specimen at a 95% prediction interval on the load at failure for this specimen is. So now we have to solve this by using the same still formula like earlier. So let's get diving into it. The formula we are using is x bar plus minus t 1 minus alpha n minus 1 times standard deviation square root of 1 plus 1 over the sample size. Input the value, we got 13.71 plus minus 2.08 times 3.55 square root of 1 plus 1 over 22, which give us the value of 6.16 and 21.26. The prediction interval is considerably longer than the confidence interval. This is because the confidence interval is an estimate of a parameter, but the prediction is an estimate for future observations, in which on the 23rd specimen at a 95% prediction interval, on the load at failure, we got a 6.16 and 21.26.